Hello, we are again back with another lecture on atomic structure. We will not discuss new model. We are again reviewing our journey from planetary model to electron cloud model. That is, our journey will start from 1913 and reach back to 1932. But we will get down at each station if we are comparing this or taking analogy of our journey in railway. So we will get down at each railway station. We will go through the platform, walk through the platform and see the things, and then get into the train again and reach the next platform. So let us see, what do we see? We are starting with planetary model, that is Bohr's atomic model proposed in 1913. According to this model, electrons revolve in discrete orbits with fixed energies. For hydrogen atom, energy levels are given as E is equal to minus 13.6 divided by n square, expressed in electron volt unit. This n is energy level. Radiation occurs when electrons jump between energy levels. Radiation occurs means when electron jump from higher to lower energy, radiation is emitted. Lower to higher energy level, radiation is absorbed. This explained hydrogen spectrum successfully, but failed to explain multi-electron atoms. Here, we are seeing the video of Bohr's model. This model introduced quantization in atomic structure, the foundation for quantum theory. This laid the foundation for quantum theory. So let us go into the hydrogen emission spectrum. Hydrogen emits light of specific wavelengths, discrete lines. It's not continuous spectrum. These lines were explained by Bohr's quantized energy levels. Rydberg formula explained it more. The formula is 1 by lambda, that is equal to Rydberg constant, multiplied with 1 by n1 square minus 1 by n2 square, where n1 and n2 are different energy levels. From 1 to 2, electron is jumping. This confirmed quantized nature of atomic energy levels. Now, in the video, you can see N, M, and L are mentioned. These are different quantum numbers. We will go through them in detail in our later slides. And also you can see chi square is shown. This is wave function that will be explained in quantum mechanical model. And this present model, Bohr's atomic model, this provided actually this Rydberg formula and hydrogen emission spectrum. This provided experimental evidence for Bohr's atomic model. Let us move on to the next one. In 1905, earlier to Bohr's model, Einstein gave his photoelectric effect idea or theory. We cannot say idea. Light behaves as particle, that is known as photons, packets of energy, with energy given as E is equal to h nu, where h is Planck's constant. This constant was given by Planck, scientist Planck, and nu is the frequency of the radiation. Electrons are ejected from a metal when photon energy exceeds work function phi. That is, when electrons receive energy, then if enough energy is received, and when it is receiving energy, it is getting more energized, its kinetic energy is increasing when it is increasing so much that it can leave the atom, then it is leaving the metal surface. So the equation is h nu is equal to pi plus half mv square. Pi is the threshold energy which is needed by the electron to leave the metal surface. So his photoelectric effect theory explained threshold frequency and instantaneous emission. Impact on atomic model was that it confirmed quantum nature of light and supported wave-particle duality. Then in 1926, as we had learned earlier in the last video, this electron cloud model or quantum mechanical model was developed by Schrödinger and Heisenberg. Electrons exhibit wave nature and are described by wave function. I'm so sorry. Somehow my mouse is not helping me to stay here. I think it has received energy, or I am losing energy because it's my breakfast time. Anyways, let us continue with this. Electrons exhibit wave nature and are described by wave function. Wave function, we had discussed this. Square of the wave function, probability distribution. So it gives chance of finding an electron. Square of wave function means it's the probability of finding the electron in space. The maximum density, maximum value of probability distribution means it's the maximum chance that electron will be found in that space. Orbitals replace Bohr's fixed orbits in this model. Heisenberg's uncertainty principle, which tells that we cannot know simultaneously the position and momentum of an electron with certainty. One, say we are trying to know the position of the electron precisely, then calculation of the momentum, determination of momentum will go far away from accuracy. And if we try to accurately know or calculate momentum, then we cannot know the position accurately. So, sorry, precision may be there, but accuracy won't be there. This is Heisenberg's uncertainty principle. Impact, that is modern understanding of atomic structure based on quantum probability. Now we are not saying electron is orbiting in this circular path. Rather, we are saying this is the maximum probable space where electron can be found. Then electron configuration, that is knowing the address of the electron. So let me put down my auto or my video little down so that you can see the other videos. Oh, I'm sorry. Yes. Sorry again. Yes, now the video is running properly. So, electronic configuration, we were discussing arrangement of electrons in atomic orbitals. How we arrange them or how they are arranged and how we calculate that. Upper principle, that is lowest energy orbitals are filled fast. Then Pauli's exclusion principle that tells that maximum 2 electrons per orbital with opposite spins can be there. Hund's rule tells that orbitals of equal energy will be filled singly first, that is half filled, because they can hold 2 electrons. And if we go for example, then Hydrogen, for hydrogen, it will be 1s1. Oxygen, it is having 6 electrons. So 1s2, 2s2, 2p4. 2s and 2p are almost at the same energy level. Then iron, it will be having configuration of argon, noble gas. We will discuss all these things in periodic table video or periodic table lecture again. So iron will be having argon's configuration and then continuing with 4s2, 3d6. Now, Abbas principle is shown in the video, this one, this one. Okay, so this how it is taking place, how these things are filling up. And this is about argon's electron configuration, Pauli's and exclusion principle, and Hard's rule. So basically, if we take analogy of a building, where, say, any building where we are residing, say it is a multi-storied apartment. So in the ground level, there is only one room which can hold maximum 2 persons. One double bedroom is there. Okay. In the floor above that, there are two rooms. In one bedroom with double bed capacity, and in the other bedroom, three bedrooms are there with each bedroom having a double bed capacity. If we talk about oxygen, the ground level is filled, 2 persons already living there, sharing the bed. In the next floor, above that ground floor, the first flat, which is having one bedroom that is filled, 2 persons living there, and in the rest three flats, there are one bedroom in each. And how many persons are staying? 4 persons are sharing that 3 bedroom. So 1 person each will be placed in one bedroom, and then one more extra person will be going to any one of the bedroom, right? So on and so forth. I hope I could explain it. So our chapter summary. Let us view from Thomson's model to quantum model the whole modern concept. That is, Thomson in 1897 discovered electron atoms were found to be divisible. Then Rutherford, nucleus was discovered in 1911. So atom is mostly empty space with a dense nucleus inside. Then Bohr came up with his model in 1913. Quantized orbits explained hydrogen spectra. Then Einstein in 1905, not then, prior to Bohr, Einstein in 1905 gave his theory of photoelectric effect, which showed dual nature of light, particulate nature, and radiation nature, or wave nature, better to say. So this particulate nature means packets of energy. Like we have packets of noodles, though noodles are made continuous in the industry, but when it is coming to market, we have packets of that, right? Schrödinger in 1926 talked about wave equation. Orbitals came into picture, not orbit, not fixed orbits. And after that, Chadwick in 1932 talked about neutron. He discovered neutrons and completed atomic model. So this is the journey of atomic models, unified classical quantum views into modern atomic theory. That was the impact. So lesson check, Thomson to Chadwick. Thomson's cathode ray experiment discovered, obviously, electron. Millikan measured the charge of electron. Rutherford's gold foil experiment. Oh, I'm sorry. this one has come in between. I don't know from where it has jumped. Maybe it has got some energy and jumped into gold, or it was above somewhere and it has radiated some energy and came inside this gold. Anyways, this one should not be there. It is Rutherford's gold foil experiment. So what did it reveal? Dense positively charged nucleus. Rutherford's bombardment of nitrogen. What did it confirm? Presence of proton. And Chadwick, he discovered neutron using beryllium. He bombarded alpha particle at beryllium target, and the emitted particle was found to be charged less neutral particle and having mass same as proton. It was named as neutron. And few more lesson check questions. Board explained discrete line spectra using Bohr's discrete energy level model. Hydrogen emission spectrum got supported, hydrogen emission spectrum supported what? Quantized orbits. Photoelectric effect proved light's which nature? Particle nature. Schrödinger introduced wave mechanical model. And the last one, Oppo principle. What did it explain? Lowest energy orbitals should get filled first. And thank you. So every electron tells a quantum story. Keep exploring. Okay. Maybe one more later sometime. If you ask me enough questions, I will come up with one more video. But till then, as long as you are going through it, asking me questions, till then, bye. Thank you. And we will come up with next lecture in this series in next video. Bye. Stay blessed and stay well. Yeah.